So let's talk inverses. What's the inverse of this first figure, 2x plus 1? What would the inverse be? Well, not the equation of it.
Oh, it should be x plus y.
It would be a line, right? We're being way too complicated. Okay, it would be a line, and the way that I would find the line would either be to exchange x and y and solve for y, or I could just use the points. So if the point here is 0, 1, I would just do 1, 0. What's another point? 1, 1, 2, 3. So instead of 1, 3, it would be 3, 1, 1, 2, 3, 1. And it would be a line like this. Let's see. Yeah? Pretty good. All right, what about this one? What about x squared plus 3? This is a parabola. What would the inverse be? No. It would be the square root of x. Right? Yes, it would be the square root. It would be x minus the square root of x minus 3. All right, so since this vertex is at 0, 1, 2, 3, my next vertex is going to be at 3, 0. I can just graph that easily. 1, 1, and 1, 2, 3, 4, up 2. I only use half of it, right? Because the other half is actually not a function, so we can't use that part. Yes? How would I write it out again? What do you mean? Oh, so if I actually wanted to do that algebraically, I would do y equals x squared plus 3, switch them, x equals y squared plus 3, move the 3 over, x minus 3 equals y squared, and then I would take the square root of both sides. Does that help? You're welcome. So then I'm just going to switch them. Y equals the square root of x minus 3. Okay, and what about this one? This cubic function. We cube root, right? And the cube root, since it starts at 0, 3, would start at 3, 0. And then I know that if I take the cube root of 1, I get 1, and the cube root of 8, which will be way down here, is 2. Looks something like that. I always like graphing these. I think they look so cool. All right, so now we've come to exponential functions. And I've been sharing with you that the inverse of an exponential is a logarithmic. And this is what it looks like. So if our exponential, the magic number or reference point is 0, 1, then what's my logarithmic magic number or reference point going to be? It's going to be 1, 0. If I go over 1 and up 2, I'm going to go over 2 and up 1. If I go over 2, sorry, that was over 1, up 2. If I go over 2 and up 1, 2, 3, 4, I'm going to go over 1, 2, 3, 4, up 2. It's going to look just like this, and then it's going to have its asymptote on the y-axis instead of the x-axis. So that's a logarithmic function. We're not going to spend a lot of time because they look just like an exponential with all the same rules, right? They're just tipped on the other side. Okay, so let's start here. Students will be able to translate expressions between exponential and logarithmic. So I'm just going to show you what it looks like, and then we're going to be able to go from one to the other. Okay? We're going to be able to go back and forth. All right. Can you guess what goes on that line? Right here. Anybody have a guess? Okay, so you guys did a good job. Turn to your table partners and discuss how you know what number goes in the line. And who'd like to share? Amadeus, what'd you come up with? Whatever the exponent is. But we don't usually put exponents in a box like this and then have the number next to them, right? Two to the 3 makes 8. That box is just a clue, right, of what you should do. This is the base. 2 is the base. You're going to see. Okay, let's get better at this. Okay, see why? 2 to the negative 1 makes a half, right? Right? To make a 3 a 9, we got to square it, but we have to make it negative so that it is now a fraction. These are a little harder. Right? 9 to the 1/2 is just like putting a square root over 9. Are we okay? We need to absorb that for a second. That's a harder one to see. Next. It looks weird, huh? It's the same. It's just like putting a square root over it, right? Because you can't evaluate the square root of 2, so it's just the square root of 2. Make sense? One-third, right? So to get from 8, anytime we have to get from a bigger number to a smaller number, we are using a fractional exponent, right? Have you noticed that? Okay. And this one? Okay, so ask yourself, are we getting bigger or getting smaller? We're getting bigger. Well, the number is, not the number, the digit in there is getting bigger, so we know we have to be using a number bigger than 1, right? But it's not the denominator. I mean, it is, but that's not what I'm trying to say. But since it has to be 4 to get to 16, but to make it a fraction, we make it negative. Does that make sense? We're going to get to practice. What about this one? And what about this one? What about this one? Okay, so my point is, this is a special case, right? When you have a base, when you have the answer 1, it's always going to have, you never know what the base could be, because the answer is always going to be 1. All right. So why don't you guys do those on your desk, and then I'll show you the answers. Give us like 2 minutes. All right, let's look at the answer to these. This one doesn't work, right here. And the reason this one doesn't work is because you can't get a negative number from a positive base. Does that make sense?
Yeah.
There's nothing I can do to get a negative number from a positive base. Now, if I had a negative number, right, I mean a negative base, and I took it to an exponent, I could get a negative number, right? So that one doesn't work. Questions on any of them? We're good so far? Ready for me to step it up a little bit? Okay. Here we go. You guys ready? Okay, so we all agree that the answer to this is 3. All right? This is what it's really supposed to look like. I've been tricking you. There's no such thing as this. We call this the B box. I call it the B box because it's the base with a box, the B box. This is actually a logarithm. Okay, but it looks funny, right? So this is how you would say this. This is how I would say this. I would say the log with base 2, right, when it's raised to the 3rd power is 8. It's not bad, it's just it looks different. It's going to take a little bit for you to train your mind on what it looks like. So whenever you see it, whenever you see a log and it has a little tiny number, that's actually the base of an exponential number. Yeah. And so 2 to the 3 equals 8. All right, so remember I told you when we were doing Desmos, and we were trying to find, and we used Desmos to solve those problems that had time, we were trying to, something like 2 to the 1.1 to the t. We were trying to find at what time. Well, now we're going to use logarithms to find that t, because logarithms are exponents. Logarithms equal exponents. I'll say it again. Logarithms equal exponent. Isn't that the exponent?
Yes.
So the logarithm is finding the exponent. Okay, that's what we're doing. We're using the inverse to find the exponent. Yes, Jonathan? I want everybody to try the next one. Do you think you can write the next one on your board, what it's going to, or on your table, what it's going to look like? All right. Here's my unveiling. So log base 5 to the 25 equals 2. You guys ready to practice? Okay. But do you see what I mean by this was going to look very different? Okay. So this is the way I say it in my head. I spent some time this morning putting these new slides in. This is, when you're trying to evaluate a logarithm, I always start with what we're looking for. We're looking for the exponent. So I ask myself, what exponent with this base gives me this number? So 5 to the 3 gives me 125. I'm finding exponents, right? I'm trying to find the exponent to the base. What about this one? What exponent with this base gives me this number, 3. Ready for me to step it up? What exponent with this base gives me this number? Right? Yeah. You just have to think, guys, you have to think about the fact, I know sometimes it gets confusing with these fractions, but you need to ask yourself, is the digit getting larger? If the digit's getting larger, it has to be, the exponent has to be a whole number, right? If the digit's getting smaller, like if it was 25 to 5, then you'd have to use a fraction, right? So the digits, are the digits getting bigger or smaller? That'll kind of help you a little bit. Does that help? Okay. Some of you, hopefully. Not going to help everybody? Okay, so now you ask yourself, is the digit getting smaller? No, it's getting bigger, right? So it's squared. To get from 3 to 9, I need to square it, but to get from a fraction to a whole number, I need to take the inverse, right? Or not the inverse. I need it to, I don't want to use flip. You know what I'm saying, but I'd rather use something a little bit that's got the proper terminology. I'm kind of going from, I want to go from fractions to whole numbers, right? And so I would use a negative. Okay, I don't think I have any harder than that. Yeah, so why don't you guys practice those, and I'll give you the answers in about 2 minutes. 1. All right, let's look at the answers to these. Do we have questions on any of them? Which one? Number 7. How do you get, so I've got a base of 36. Base of 36. I need to know what exponent I need to get to 6. Right? Well, if I'm going from a big digit to a smaller digit, I'm going to need a fraction. Right? Because 36, square root of 36 is 6. Another way to write the square root of 36 is 36 to the 1/2.
So that's losing a fraction to number 3.
Yep, it ends up being fractional. Does that help?
And what number is the
It's getting bigger, but it's now in the it's becoming a fraction, so the negative exponent makes it a smaller number. Make sense? Okay. I want to show you the next one. I'm not going to have you do these. Okay, you guys? Let's look at this. Let's look at the, I'm tired of talking over everybody. Can we shut, Molly, can you shut that door for me, please, so we don't have that beeping? Fantastic, thank you. I want you guys to look at the last 2. These look a little different. The only difference with these is that if E is involved, Michael, if E is involved, it gets its own special name. It's called a natural log. I know, it's crazy. Let me just show you. When you on a calculator, when you see this, what goes right here? If there's nothing there, what does it mean? It's a 2, right? It's a square root. Just like this is a cube root, and this is a 4th root. If there's nothing there, the calculator automatically assumes that it's got a 2 there. All right? On your calculator, it's going to have a log button. If there's no number there, there's no base, nope, the calculator is going to assume it's a base 10. Base 10 is what it's called a common log, and you'll learn about it a little bit later, but on your calculator, it's log base 10. A natural log has a base of E. Okay? It's not going to show it on your calculator, but it has a base of e, and it's called a natural log. It's a special one. Okay, so if you have something like this, that's the natural log e cubed, natural log e, this is what you're really seeing. Now, I know this is funny to say, and it looks very obvious, but what do I need to do to e? What do I need to do to my base? What exponent do I need to get e cubed? 3. Because e to the 3 is e to the 3. Make sense? So if I give you ln e to the 5, what exponent do I need to get e to the 5? 5. It's almost too simple. ln is not, they're the same thing, only this one is especially reserved for e. We'll talk about it more later, okay? Remember, I'm just exposing, I don't want to give you too much information today, I'm just exposing it to you, okay? Alright, so we're going to do one more exercise and then we're done with this for today. And this is going to be your worksheet, and we're only going to do the front of it, and it took me literally 2 minutes to do the worksheet. So it's quick. All it is meant for you just to practice, okay? Alright, so first we're going to rewrite in exponential form. So I have a logarithm, and I'm going to rewrite it in exponential form. So if I see this, I say to myself, that's just like saying base 12 with an exponent of 2 makes 144. Make sense? So that's all we're doing. We're just changing it from logarithmic to exponential. So you guys try this one. Yes. I'm not understanding what you're asking. Think about it and come back. Try this one. We're not solving for anything. The answer is already up there, right? We're just putting it in the other form. That's it. You're just changing form. Christian? Everybody should be doing it on their desk. The one that's not done. Okay, so I have a base of 2 to the 6th power equals 64. This one I have, go ahead, try that one. You know you do it right, because if you did it right, then it should be correct. Does that make sense? So base of 4 cubed equals 64. Is that true? Yes, and we did it right. What about this one? Try this one. So base 6, the exponent of a 2 equals 36. To me, this is the easiest way to go. When I see a logarithm and I go, wait a second, what does that mean again? I just put it into exponential form and then it makes sense to me. You know what I mean? Okay, let's try it the other way. The other way is it's not hard, it's just a little more of a challenge. So I'll do the first one for you. So this time we're going from exponential and we're going to put it in logarithmic. Log base 2, 64. The base is, thank you, the base is 8. Thank you, that's what it is. Base 8, 64 equals 2. Okay, you want to hear what Easton told me at lunch? It's actually pretty good. He's got a song or a rhyme for this. It's pretty good. Big gets small, small gets big, answer stays the same. Big gets small, small gets big, but the answer stays the same.
I like it.
I like it too. Do you have to use it? No. So we don't have to complain, right? Just don't use it if you don't like it. Yes. Yeah, the numbers aren't going to change. All you're doing is just putting it in you're just putting it in a different form. That's it. It's just a way to look at things differently. Because this is what happens. I'm waiting. So when we don't have an answer for an exponent, if we turn it into a logarithm, then we can use properties of logarithms to solve for it. Does that make sense? So next we're going to learn properties of logarithms that happen to be the same as the properties of exponents, the rules of exponents that I was just having you practice. So that's why I had you guys do that. They're the same rules for logarithms. They just look a little bit different. Okay? All right. Can you write that one? So it's log base 3, 81 equals 4. I don't know why. I just have a harder time doing it this way. I really have to think about it. I don't know why. And that one? Log base 2, 32 equals 5. Big gets small, small gets big, answer stays the same. So log base 5, 125 equals 3. And what are logarithms again? Exponents, right? Logarithms equal exponents. Literally. Right? I got it up on the board like every single time. Logs equal exponents. Okay, so now we're going to practice a little bit. Should take you no longer than 5 minutes, maybe 10 at the most if you're talking. And I think I'm going to stop the recording at that. All right.